we are going to discuss about the basic considerations for the design and development of technology, namely access, affordability and availability. Information communication technology infrastructure implies the telecommunication and information networks which transmit, store and deliver the information. The infrastructure in the special education context embraces a wide range of devices. Traditional corporate approaches to information communication technology management are too inflexible to satisfy the needs. It is vital that the infrastructure is designed from the user's viewpoint. In order to ensure that the information communication technology devices used are suitable and appropriate for the needs of individual students, it is very important to assess regularly the level of training and support provided for students and teachers. Information communication technology offers a range of possibilities to the blind and partially sighted. The computer can be used as an intelligent interface between the visually impaired and the sighted. Information that would otherwise be inaccessible or require manual processing to become accessible can be automatically transferred into formats better suited for the visually impaired. As technologies emerge and mature, technologies that were used solely as enabling technologies in the past are becoming mainstream, thus affecting price as well as the quality. And finally, the ability to establish a virtual framework through the use of computers, geography and physical location matters less, hence increasing the opportunities in terms of employment and education. Students with special needs must have access to information communication technology based equipment being a part of the general school program. The main role of information communication technologies in the special needs education setting can be considered as meeting a variety of individual learners' needs via an appropriate technical infrastructure. Any educational activity, planning the curriculum, delivering instruction material, managing assessment and communicating with students can be extended and enhanced through the use of an appropriate learning platform. That the computer can be used as an intelligent interface between the visually impaired and the sighted is not new. For years, visually impaired have been able to command the user interfaces of computers using screen readers, speech synthesis, braille displays and screen magnification systems. Furthermore, the visually impaired have access to the vast majority of all business applications, personal productivity tools, office applications, email systems and web browsers. Using enabling technologies in combination with general purpose computer systems, the blind and partially sighted have been able to transform information from formats aimed at the sighted into formats more suitable to meet the needs of the visually impaired. Enabling technologies for such automatic transformation include braille translation systems, screen magnification systems and text-to-speech engines. In view of the fact that there is no unique set of tools and no single learning platform that will suit each and every institution, this section primarily focuses on the design principles which drive technology and the functional criteria with which technology can and must help specialists improve learning environment. While the policy principles may be relatively immutable, that is, the inclusion and equality of educational opportunities must always be the focus, as well as quality and efficiency must always be improved. The priorities for subsector allocation of resources can vary from one country to other depending on economic and social circumstances. Minding that today's users' demand turn out to be much more complicated than a plain imperative to cut costs, the key user needs are discussed. The first and foremost important need is the usability. It is clear that if people cannot use it, they won't use it. A well-designed educational information communication technology platform has to provide a consistent interface across its functions, interoperation with various assistive technology devices, easy access and navigation to the required content, a single ID and logon, and a single point of contact for technical support and course related inquiries. For managers and administrators, a simple means of tracking individual user performance and viewing individual user records is also needed. The most appropriate way to ensure the usability of applied technologies is through involvement of end users. Initiatives must therefore include social assessment as a central dimension. The primitive user need is the accessibility. Facilities of information access must embrace all users regardless of their physical ability. One of the central issues in education of people with special education needs is that technologies providing the access to information resources should be tailored to the needs of various users. The applied design for all principles, starting with the invention phase in the development life cycle, play a major role in improving the accessibility of living environments for people with disabilities. The task of listing all such problems is not easy, mainly because students with visual disabilities are a highly inhomogeneous category, showing a wide range of different specific abilities, disabilities and needs. Blind and low vision students, for instance, despite the fact that they are both often simply referred to as visually impaired, present very different problems, find different obstacles and ask for different kinds of help and support. What's more, even the category of low vision students is a highly heterogeneous one. It encompasses a wide variety of different visual characteristics. In this perspective, the different instructional tools, those information communication technology based as well as the traditional ones, may meet or not to the needs of each single user depending on his or her specific impairment. After a brief review of the e-learning tools that are widely used for educational purposes, examples are provided of some problems encountered by students with visual disabilities in accessing and using e-learning material. Such problems often result into true obstacles for the effective use of tools and may also have a negative influence on the overall learning process. The third most important user need is the flexibility. The ability of a product design to accommodate changes of design criteria that may occur after the design has been completed. Designers may over-design by choosing equipment at the high end of available alternatives to accommodate future advancement of support equipment. The technical platform must inherit the capacity to alter and integrate with non-standard products when necessary. Learners, for example, must be able to access the platform from the widest possible range of computing and communications equipment, and once online, customize their operating environment to the way they work and choose from a range of routes through the learning material. Course designers must be able to customize their workflow, enjoy an unrestricted choice of media, and freely adapt core material to local needs. Teachers must be able to deal with learners as individuals or assemble them into whichever groupings best suit a particular course module. Service providers or administrators must be free to choose which part of the platform they source from which supplier and which hardware they can use to run which applications. The most important user criteria is affordability. Due to the fact that the disabled people often have low incomes as per the World Health Organization statistics, and many of them are still at the risk of poverty, public financial support is an important factor. Initiatives must, therefore, actively address the financial dimension and ensure that the lack of income does not exclude those who could benefit the most. Another important criterion is the cost. Successful information communication technology implementation in special education will depend to a large extent on faster and more effectiveness, reliable access and lower communication costs. However, it is known that equipping special education needs with new technologies requires additional financing, as simple information communication technology devices must be adapted to the needs of users with disabilities. Furthermore, our technological platform must be powerful and future rich. Required characteristics therefore will include interoperability for quick low cost connection to the existing data stored and information systems, reusability and portability of courseware to maximize return of investment and promote competitiveness among vendors, manageability to ensure maximum system productivity at any time, user accessibility to ensure the best use of available working hours, durability to avoid costly technology obsolescence. Now let us discuss the challenges in enabling technologies for the visually impaired people. Although enabling technologies developed specially for people with special needs represent powerful tools, these enabling technologies are typically developed using proprietary technology. Their limited markets result in relatively high prices while at the same time demonstrating rather low quality. The manufacturer cannot be held to blame for this. The high price low quality relation is simply a reflection of the market conditions. However, in recent years, many technologies that used to be utilized more or less exclusively as enabling technologies are being adopted by the mainstream market. The result could be high quality, low price products based on industry standards. An example of a technology that is being adopted by the mainstream market is speech synthesis or voice recognition. As talking computers, voice controlled computer interfaces and voice response systems become the norm, the quality of speech synthesis and voice recognition will improve while the prices of these technologies will drop. Likewise, as more and more people begin to use portable handheld computers such as palm top computers and mobile telephones to access information on the internet and elsewhere, current restrictions on bandwidth, navigation and accessibility will be lifted. The handheld computers have many of the same characteristics as we know from enabling technologies, including limited displays, poor resolution, limited power supply and slow network connection, whereas the information providers may be able to get away with not providing access to people with special needs on their internet sites. The general public and especially the business community will not accept these limitations. Finally, let us have a word on the electronic books. The main problems relating to having access to electronic versions of printed material are copyright and copy protection issues. As electronic books becomes an integral part of any publishing activity in the mainstream market, these issues are bound to be resolved. Once available as an electronic book within a framework that protects the rights of authors and publishers, little needs to be done to ensure that the books can be rendered in formats suitable for the blind and partially sighted. Now let us discuss two of the most important barriers in accessibility. The first one is inaccessible web design. The power of the web lies in its universality. Access by everyone regardless of disability is an essential aspect. This statement has been made by Tim Berners-Lee, the inventor of World Wide Web and currently the director of World Wide Web Consortium. Within this context, it can be argued that accessibility is really a matter of providing as many people in as many different situations and from as many different browser platforms with access to web based information. It should not matter whether the user is disabled, whether he or she browses using a mobile telephone in a car without the ability to use hands and eyes, or whether he or she uses a non-mainstream platform such as a palm top computer while accessing the internet. Yet, the fact is that the web is not accessible. There is growing interest to address the issue of inaccessible web design. Especially public institutions are under pressure to improve their sites, at least from the point of view of political correctness. The solution may however come from a different angle. As mentioned earlier, portable handheld computers such as palm top computers and mobile technologies share many of the characteristics of enabling technologies. Websites that are inaccessible or difficult to use by the disabled users will be similarly inaccessible and difficult to use by the mainstream users. The second most important aspect is erosion of basic skills. Over the past 30 years, Braille literacy has shown a dramatic decline. In America and the United Kingdom, alarming statistics have been published, and although less significant, similar trends are reported from other countries including India. Many people fail to recognize the importance of Braille. It is difficult to learn as a visually impaired person, difficult to read and understand as a sighted person. It is costly and time consuming to produce, and Braille devices such as Braille printers and Braille displays are expensive. In many cases, speech synthesis appears to be an attractive alternative. However, a symbolic written medium is as important for the blind as it is for the sighted. Braille is a fundamental means of communicating and plays a significant role in the process of intellectual development. It is so much more effective to be an active reader than a passive listener. Furthermore, Braille literacy is an integral part of the personal identity for visually impaired people. In general, lack of Braille skills equals illiteracy, a rather serious issue in the information society. Technology promotes autonomy and independence of persons with disabilities. Technological advancements has greatly contributed to changing social attitudes towards disability. Assistive technologies refers to products, services and practices that persons with disabilities use to minimize the impact of impairment and gain access to environments and activities, thus improving and increasing their full participation. Various classifications of technologies exist and they can be used depending on the purpose, such as cataloging, teaching, information exchange, organization of counseling services, etc. The classification best suited for structuring educational programs should be knowledge oriented. Technological benefits for students with disabilities are evident in making them able to undertake regular school activities. Nevertheless, technological development sometimes can exacerbate segregation of such persons. At the same time, however, information technology and the ways in which the technology is deployed represent an equal range of challenges. Although the internet in theory makes information available to anyone who can use a computer, poor web design raises new barriers. Furthermore, the short learning curve combined with relatively expensive solutions based on speech synthesis may further erode basic skills for visually impaired people such as Braille literacy.